Go ahead and start chapter 4, section 3, simplifying fractional expressions. Part 1, finding equivalent fractions. So we're going to make equivalent fractions. Let's start with this. Make equivalent fractions. You can do them a couple different ways, but we're going to kind of focus on one way first. By multiplying, you can actually also divide, but we're going to focus on multiplying both the numerator and denominator. I'm going to abbreviate that by the same factor, by the same number. Okay, so in these two examples right here for A and B, we're just going to do what the instructions say, which is multiply the numerator and denominator by 5. So that's what we're going to do. So we're going to multiply the top by 5 and multiply the bottom by 5. And that comes out to 20 over 35. So everything got multiplied by 5. Now, just so you know, 5 over 5, if you recognize that, 5 over 5 is just a fancy schmancy factor or fraction way of writing 1, right? That's what we just did there. So you're multiplying by 1. And if you multiply something by 1, what do you get? You get the same thing, right? Nothing really changed if you multiply a number by 1. Now, obviously, 4/7 is different numbers than 20 over 35, but the fraction itself is equivalent. That's equal, right? It's the same thing. It represents, someone said, hey, I had 4/7 of the pizza, and someone else said, oh, well, I had 20/35, right? So definitely sounds like 20/35 is more, but it's not, right? It's the same part of a whole, okay? Right here, we're going to multiply the numerator and denominator by 2x. Pardon me. So we're going to multiply that by 2x, and we're going to multiply this by 2x, and so you get, what do you get? You get, we got 8x over 14x. That's it. Okay. Part 2, making equivalent fractions. Let's make equivalent fractions here with a denominator of 24, which is basically leading into, like when you add or subtract fractions, you have to change the fractions with a new denominator. So, and when you change things with a new denominator, you're going to have to change the numerator proportionally, okay? So what's going on here? So if we change it by 24, we just look at, okay, what are we multiplying 8 by? Well, 8 times, I wrote 4. 8 times 3 is 24. You're going to multiply the numerator by the same factor. So 7 times 3 is 21. Okay? All right, that's that one. All right, doing the same thing here. So just start with the numbers that you can compare. 9 and 54. We can see what we have to multiply that by. 9 times 6 is 54. Well, we're going to do the same thing to the top. 4 times 6, which is 24. Okay. Right here, we're gonna multiply. What do we have to multiply 6 by to get 18x? Well, we have to multiply by 3x. 6 times 3x is 18x. Do the same thing to 5x. So we're going to multiply that by 3x, and you get 15x. All right, moving on to the next page here. We got part 3, reducing fractions to lowest terms. A fraction is considered in lowest terms or simplest form. It's in lowest terms when the numerator and denominator have a common factor of 1. Okay, so break the numerator and denominator into prime factors. That's one way you can do it. I think this is, because sometimes reducing fractions is, for whatever reason, some people don't always get it down to simplest form. They reduce it perhaps, but not low enough where it's in simplest form. So we can break it down into prime factors. So 16, for instance, 16 is what? 2 times 2 times 2 times 2, right? 28 is 2 times 2 times 7. That's where if you do factor trees, you got 2 and 14 and 2 and 7. That's what I'm just doing. I'm just foregoing that step of showing you the factor trees, but you can kind of do that on your own. And then what you want to do is if you break it down into just prime factors, these strings of prime products, you can kind of cancel stuff off. That pair of twos cancel. This pair of twos cancel. No more twos to cancel. So you have two twos left here and you have 7. So what does that turn into? That turns into 4 over 7. That simplifies to 4/7. Okay. Now, when we do 24, now 24 can be written as what? 2 times 2 times 2 times 3. And 36 can be written as 2 times 2 times 3 times 3. Now I'm going to start canceling stuff off. That pair of twos cancels. This pair cancels. And a pair of threes cancel. And then you can see what's left right here. All that's left is a 2 and a 3, and that's your prime factorization right there. Okay, or not your prime factorization, but your simplified fraction. 2/3. Okay. The other method is to divide the numerator and denominator by a common factor. Just any number that you can divide the top and the bottom by, doesn't matter, as long as it's not 1, because 1 is not going to really take you anywhere. Or you can use the GCF, the greatest common factor. Okay. So like right here, we've got 30 over negative 42. So let's say we use the greatest common factor, which is 6, So if we divide by 6, divide the top by 6, and divide the bottom by 6. Now 6 is the biggest number that can divide into 30, and the operative word here is and. It can divide into 30 and 42. So 30 divided by 6 is 5. 42 divided by 6 is 7. And that's going to be -7 because there's a negative in front of that 42. Okay. Same thing with this one. The biggest number that can divide into 48 and 56 is 8. So we can divide by 8. Now these both have a negative. So those negatives can cancel. We can just get rid of those and it's going to be positive. So this comes out to 6 over 7. 6/7. All right. 64 can be divided by what? 8. And so can, and I'm not using the greatest common factor because no one's going to think of this, but you can divide by 8. All right. And you're going to get what? We're going to get 8. And instead of writing n squared, I'm going to write n times n. And then I'm going to get, right, 9. Oh, that is greatest common factor. I don't know why I did that. And then those n's cancel right there. And that's going to be it. So it's going to be 8/9 n. Or just leave the n in the numerator like that. Okay, on this one right here, we can cancel off the x's. Just get that over with. All we're left with is a y. And on this one, we can divide by what? 6, right? We can get 6. So we got 42 divided by 6, or 24 divided by 6, and 42 divided by 6. Now, 24 divided by 6 is 4. And there's a y there, so I'll leave the y on there. And then 42 divided by 6 is 7.